All right, ladies and gentlemen, good morning. What we're going to do is we're going to go ahead and solve for the reaction forces. And after we do that, by using sum of moments and sum of forces in the x and y, we're going to do the method of joints to record the, to determine the force that's in member AC, member BC, and member AB. So here we go. First thing is sum of moments, so we have to draw in our reaction forces. The reaction force at B in the Y, reaction force at C in the Y, and reaction force at C in the X. Next, we got to look at our moments, and we use our pivot, our pin support as the pivot. So this 50 pound is also going to cause a clockwise and negative moment. So that means this reaction has to be counterclockwise and a positive moment. So these two will be equal to this one, is kind of the sum of moments deal. So 50 times 5 plus 30 times 1 equals RFBY times 5. And 5 and that is, what is that? 56, I think. So 250 plus 30 is 280. Divided by 5. 5 goes into that 56 times pounds of force. That is RFBY. And we know this needs to go up because it has to force a counterclockwise rotation. 56 pounds of force. Alternatively, you could have said negative 50 times 5 minus 30 times 1 plus RFBY times 5 equals 0, but you would have gotten to here anyway, or either way, I should say. So now that I know that is 56 pounds, I need to determine what RFCY is. And my Y forces, I've got 30 coming down, I got 56 going up. So that means that RFCY is going to have to be going down, and it's going to be the difference between those. So RFCY is 26 pounds going down. 26 pounds force. And some of the forces in the X direction, I've got 50 going to the right, minus RFCX equals 0. It's the only other X direction force. And so RFCX is going to be 50 pounds of force. All right. Now we've got to come down here and do free body diagrams of each joint. So this has 30 coming down on it. It has 50 going to the right. And it has member AC. And it has member AB. Down here at C, we've got the reaction force in the X direction of 50 pounds of force. We've got AC, we've got BC, and we've got 26 pounds force coming down. And the last one we've got here is at B, and at B we've got member AB, we've got member BC, and we've got 56 pounds of force going up. And what I always say to do is to start at the easiest one. This has the least things going on, so we're going to start there. And what we do is the sum of the forces in the Y direction have to be 0. And I've got 56 coming up. So I'm going to need minus something, and the only thing that can go down is AB. So it'd be AB in the Y direction, we're looking at its components, equals 0. So AB in the Y is 56 pounds of force. And sum of forces in the X direction have to be 0. So I've got BC and I've got AB. And I just said that AB has to come down, which means it also goes to the right. And so if it's going to the right, then it is positive, and then BC has to be negative. So AB is going to be equal to BC, AB in the x direction, I should say. But we don't know what AB in the x is. However, we do know that AB is made up of its x and its y, x and y components. And we know AB in the y is 56 pounds of force. We found that right here. And this is AB in the x. And there are two ways we can do this. We could figure out what this angle is, right? Alternate interior angles would tell me what it is. So I could use tangent to figure out what AB in the x is. The other thing I could do is use sine to figure out what AB is. But what I want to do is use similar triangles. It's the way I like to do it. So if I made AB into a right triangle, it would be 4 feet by 5 feet. So 5 feet here and 4 feet here. 5 feet, 4 feet. And now I can do similar triangles. 56 over 5 equals ABX over 4. Cross multiply. 5 times 4 is 200. 6 times 4 is 24. Equals 5 times ABX. And divide both sides by 5. And you get ABX is, what is 5 goes into 240 times, and 24, 4.8. 44.8 pounds of force. So now I know AB in the x, and I know AB in the y. So AB is going to be, I'm going to use Pythagorean theorem, the square root of 44.8 squared plus 56 squared. And I apologize, I have to grab my calculator here. Second square root, 44.8 squared plus 56 squared. Oops. What is going on here? Let's try again. Sorry. Square root of 44.8 squared plus 56 squared. And that gives me 71.715. So, AB is equal to 71.715 pounds of force. All right. There's a lot to unpack there. We know what AB is. That's good. We know AB in the x is equal to BC. So we know BC is 44.8. And it means it's sat over here as well. And we said it has to go to the left. So over here, it's going to the right because this means it's in tension. So now I know BC. I know AB. I just have one left to find. And we'll go ahead and do that at C. And again, AB is actually going to be in compression because those arrows are drawn touching the arrowheads at A and at B. When they're drawn away, it's in tension. When they're drawn touching, it's in compression. And so the sum of the forces at C in the x direction have to be 0. And we've got minus 50. We've got plus 44.8. And so we have plus AC in the x equals 0. So AC in the x has to be 5.2 pounds of force. And some of the forces in the y at C and the y have to be 0. And we've got 26 coming down. Plus AC in the y equals 0. So AC in the y is 26 pounds of force. And therefore, square root 26 squared plus 5.2 squared will tell me how much AC is. And I'll be done. So second square root, 26 squared plus 5.2 squared, and that gives me 26.515 pounds of force. And that is my truss calculation. I hope that helped. As always, punch, like, and subscribe. Ring that bell. And if you got any questions, send me a line. Thanks a lot. Stay well. Be well. Have a good one. Bye-bye. Oh, what's AC in? It's going to be going, what did we say? It's going to be going up and to the right. So that means it's in tension. Sorry about that. Almost forgot. All right. Have a good one.